polarization. Then we will go to ray optics, because ray optics is easiest part that you people already have done in 12th class, right? So first will be basically focused on interference and diffraction, polarization. You will get many questions from these three topics. Okay, so let us discuss one by one. So first we will discuss about that interference. Okay, so interference is basically a phenomena which occurs when two or more wave overlap. Okay, so we can write also, it is a phenomena that occurs when two or more waves overlapped. Okay, so what is basically the condition of interference? So condition of interference, there are basically two major condition. Okay, so first, that source must be coherent. So whatever sources you are using, source should be coherent. Okay, what is the meaning of coherent? Coherent means phase difference is constant. Phase difference is constant. Okay, and second, that source should be monochromatic. Okay, and you know the meaning of monochromatic, right? Meaning of monochromatic is, meaning is that single wavelength, single lambda means wavelength. So what is the best source of monochromatic? Anyone knows? Which one will be the best example of monochromatic source? Any example you have? So for example, if you use laser light, so you know laser is almost monochromatic. So you can use that laser source as a monochromatic light. Okay, monochromatic light. So again I am repeating, interference is nothing but a phenomena which occur when two or more waves overlap, and that waves are basically coming from two or different sources. That source should be coherent. Coherent means the phase difference between waves that should be constant over time, and that sources should be monochromatic. Monochromatic means they will have single wavelength, right? And best example of monochromatic source is laser light. Okay, so laser light is almost monochromatic. Okay, now there are basically two type of interference. One is constructive interference. Okay, so you can mention here point A, that is your constructive interference. So suppose you have a two waves. Suppose you have a waves A. Okay, this is your waves A, and you have another waves. That is your B waves. Okay, and they are superimposed. So waves A is making superimpose with waves B. Okay, and you can see they are actually in same phase. They are actually in same phase, right? So when the constructive interference will occur, when two or more wave having phase difference like 0, 2 pi, 4 pi, and so on, in that case you will get constructive interference. And in constructive interference, the resultant wave will have higher amplitude compared to individual one. Okay, so this is the case of constructive interference. You can clearly see the phase difference between these two waves is how much here? How much? Zero, right? You see, zero. So constructive if you add them, then how the resultant wave will be looking like? How its amplitude will be higher, right? And you know, if amplitude is higher, it means it will be highly intense, right? Did you get what I'm saying? When they will superimpose, the resultant wave will have higher amplitude. You can see the amplitude is less. When they will superimpose, you will get resultant wave. It will have a higher amplitude. So higher amplitude means it will have high intensity, because you know intensity is proportional to amplitude square, right? So during superposition or constructive interference, you will get high intensity, or you can say the resultant wave will have a higher amplitude compared to individual one. Okay. So when it will occur? When the phase difference between waves delta phi, that will be either 0 or 2 pi or 4 pi and so on. Okay. And you know, if you know the phase difference, then how much will be the path difference? You know this relation, right? That phase difference between wave delta phi is nothing but 2 pi by lambda into path difference, right? Delta x is here path difference. So it means delta x is how much? Delta x, that path difference between wave, that will be nothing but lambda by 2 pi into delta phi, right? Now you know, for constructive interference, that phase difference is how much? 0, 2 pi, 4 pi. So you can say in other words, for constructive interference, that path difference can be what? If you substitute the delta phi here, delta phi is how much? 0, 2 pi, 4 pi. If you substitute it, you will get, for constructive interference, that path difference between wave will be how much? Either it will be 0 or lambda or 2 lambda and so on. Did you get what I'm saying? So this is the condition for constructive interference. When two or more rays which will have path difference like 0, lambda, 2 lambda and so on, then you will get constructive interference. Okay. And lambda is what here? Lambda is the wavelength of light that you are using. Okay. Did you get what I'm saying?
Yes, sir.
Yes, sir.
It means for constructive interference, you can say it will only occur when the path difference between rays will be of the order of n lambda, where n will be how much? N will be how much? Either 0 or 1 or 2 and so on, right? Is not it? Did you get what I'm saying?
Yes, sir.
Yes, sir.
Okay. Now there is other part of interference, that is your destructive interference, right? Destructive interference. Okay. So you have again two type of waves. They are making superimpose. Suppose you have wave A and you have wave B. Okay. This is your wave B. And they are making superimpose. Now you see their phase difference is how much here? Phase difference is how much? You see, one is going upwards, at the same time other is going downwards, right? So if you add them, what will happen? So you can say, suppose this is your plus 1, so it will be minus 1. If you add them, what will happen? They will cancel each other, right? Suppose this two wave will have same amplitude. Suppose this two waves is having same amplitude. Now you see, for a particular point, if you see for this wave B, Suppose this amplitude is how much? -1. At the same time, this wave is having amplitude that is +1. If you add them, what will happen? Resultant will be how much?
0.
0. Exactly. So it at this situation, if both wave is having same amplitude, the resultant will have how much? You will have 0 amplitude, right? You will get nothing here. You get what I'm saying? So when both wave are out of phase, or you can say the phase difference between these two wave is how much here? कितना है? एक आपका अपवर्ड जा रहा है, दूसरा आपका क्या है? डाउनवर्ड जा रहा है. फेज डिफरेंस कितना हो गया? 180, right? Did you get? So for wave A, you see that amplitude is going upward. For wave at the same time, for wave B, the amplitude is going in which direction? Downward direction. You see, it is going upward, it is going downward. So you see the phase difference will be how much? Phase will be 180, right?
180.
Yes, sir.
Destructive interference will only occur for what case? So when the phase difference is 180 or 3 pi, 5 pi, so on. So you can say here, for destructive interference will only occur when phase difference is how much? Either pi, 3 pi, 5 pi, and so on. Okay. Now again, you can find that part difference, because you know the part difference between ray delta x is nothing but how much? Lambda by 2 pi into delta phi, right? Okay, now if you substitute that delta phi for destructive interference, how much you will get? When you will substitute phi, delta phi equals to pi here, you will get basically how much? You will get lambda by 2, right? When you will substitute 3 pi here in place of delta phi, how much you will get? 3 lambda by 2, and so on. So it means destructive interference will only occur when the part difference between rays is either lambda by 2, 3 lambda by 2, 5 lambda by 2, so on. Okay. So you can write here डेल्टा एक्स कितना होगा अगर शॉर्ट फॉर्म में लिखना चाहोगे इट शुड बी 2n minus on 2n minus on lambda by 2 where n can be how much? N can be on 2 3 so on, right?
Yes, sir.
ठीक है ना?
Yes, sir.
Okay. इसमें जो आपका
Yes, sir.
रिजल्टेंट इंटेंसिटी और एम्पलीट्यूड होगा इट विल बी स्मॉलर एज कंपेयर टू इंडिविजुअल वेव, राइट? ठीक है ना? तो बेसिकली जो रिजल्टेंट वेव का हम एम्पलीट्यूड निकालते हैं, क्या करते हैं? बेसिकली दोनों का वेक्टर सम करते हैं. जितना आपका वेव्स है, यहाँ पे 2 वेव्स है, दोनों का वेक्टर सम करोगे. यहाँ पे 0 क्यों आया है? क्योंकि दोनों का एम्पलीट्यूड मैंने क्या एज्यूम किया है? मैंने आज आई हैव एज्यूम दैट बोथ वेव्स विल हैव सेम एम्पलीट्यूड. दैट्स व्हाई यू आर गेटिंग 0 एम्पलीट्यूड ऑफ रिजल्टेंट वेव. अगर दोनों का सेम एम्पलीट्यूड ना हो तो you will get some amplitude, but it will be smaller as compared to individual wave. Okay, is it clear? It's a basic part of your interference. Now if you understood, then we'll go to that important part of interference, that is your Young double slit experiment. Did you get this part? Do you have any
Yes, sir.
doubt on?
Yes, sir.
किसी का कोई डाउट है इसमें?
No, sir.
Okay.
No, sir.
Okay. Now we'll go to that important part of Young interference pattern, that is your Young double slit experiment. So basically, you have Young double slit experiment, then you or interference, then you will have thin film interference, then Newton string, then you will have Michelson interferometer. All are basically the part of interference. Okay. So first we will basically discuss about that Young double slit experiment. Okay. You can write in short form like OIDSE. Okay. So this experiment is basically performed in 1801, and this experiment actually it's a great achievement because this experiment proved the wave nature of light. Okay, wave nature of light. Also, another thing, this experiment also proved that. So that light is always you can say that scientists used to say that light always follow the straight line path, but this experiment shows something different. So this experiment first of all shows the wave nature of light, as well as this experiment shows that light will not always follow the straight line path. So when it will pass through a aperture or a hole having size of the order of the wavelength of light, then it will no longer pass through or follow the straight line path, but it will produce some wavelet. Okay, it will produce some wavelet. Okay, so that we are going to discuss here. So in this experiment, they have used a source that is monochromatic. Okay, and you have a slits. There are two slits, S1 and S2. Okay, and you have a screen. Okay, so when this monochromatic ray is coming, okay, it will coming like a wavelet. Okay, now you see this light is coming and passing through these two slits. Okay, the size of these slits is so small, it is of the order of millimeter. Okay, now if the light is only having particle nature, then what you are expecting? This is your screen, right? This is your screen. What you are expecting, if light is having only particle nature, then this light will pass through and you will only get two bright pattern on the screen, right? Okay, so if light is only having particle nature, you will get only two bright pattern. But when they perform this experiment, they observe something different. Okay, they observe there is a pattern of of fringes like bright, dark, bright, dark, bright, dark, and so on. Also, you see that middle part. So suppose this is your slit on, slit 2. The separation between these two slits is small d. Then center part, let us assume this is your P. तो सेंटर पार्ट क्या होना चाहिए? अगर लाइट का अगर पार्टिकल नेचर है तो सेंटर पार्ट क्या होना चाहिए आपका? बेसिकली डार्क होना चाहिए, राइट? बिकॉज पार्टिकल नेचर हो तो कहाँ पे आपका, यहाँ पे इसका कॉरस्पॉन्डिंग एक पॉइंट पे आपका ब्राइट मिलेगा और S2 से पास होगा लाइट and you will get something some bright spot here. There should be two spots if light will have only particle nature. And central point क्या होना चाहिए? Actually central point आपका क्या होना चाहिए? Dark होना चाहिए, right?
Dark.
But when they perform that experiment, they observe the central point will have bright pattern, or the intensity at central point is having highest intensity. Okay, ये point में आपका highest intensity मिला है. इसका मतलब क्या है कि जो आपका लाइट है इसका सिर्फ पार्टिकल नेचर नहीं है, इसका वेव नेचर भी है. तो ऑल्सो अनदर थिंग, अगर लाइट स्ट्रेट लाइन में पास करते हैं तब भी आपका क्या मिलता? अगर सपोज मान लो इस स्लिट से आपका लाइट पास हो रहा है, ठीक है ना? अगर स्लिट से लाइट पास हो रहा है, अगर लाइट स्ट्रेट लाइन पाथ को फॉलो करे तब भी आपको क्या मिलना चाहिए? दो ही आपका पैटर्न मिलना चाहिए, राइट? दो ही पैटर्न मिलना चाहिए, राइट? और यू कैन से दो आपको फ्रिंज मिलना चाहिए. But according to experiment, you have many number of fringes like alternative bright, dark, bright, dark, bright, dark. Then they came to conclusion that light will not always obey the straight line path. Okay. Also, they conclude that light will have wave nature. So according to them, if the size of the slit is so small or of the order of the wavelength of the light, then it will no longer follow the straight line path, but it will produce some wavelet. It will produce some wavelet, and due to superposition of this wavelet, you will get that pattern like bright, dark, and so on. So this is the basic introductory about Young double slit experiment. Now we will derive the expression of the position of this bright or dark pattern. So if you got, then we'll start the derivation. Okay. So again, I'm drawing that figure. So you have slit S1 and S2. They are separated by a distance d. You have a screen. You have a screen. Okay. Separation between that source or slit and screen, that is capital D. And capital D is much greater than small d. Okay. And suppose this is your central point P. Okay. Central point P, and you are looking at some point Q. You are looking at some point Q. Okay. Now, suppose this angle is theta. This angle is theta. And this distance PQ, this distance is how much? Let us assume this is ON. Okay. This is ON. So light will pass through this S1, right? Light will pass through this S1. Okay, and it will come to Q, point Q. Also, light will pass through this S2. Okay, and it will come to Q. Okay. Okay. Now, what will be the path difference between that light that is coming from S1 and going to Q, and that light that is coming from S2 and going to Q? So what will be the path difference between these two rays, S1Q and S2Q? So how will find that path difference? Just make a perpendicular. Okay. Now you know this angle is how much? This angle is your theta, right? अच्छा, ये angle कितना है आपका? This will be, if you have drawn perpendicular, so obviously this angle will be 90 degrees. Now, if this angle is theta, this will be how much? This will be your 90 minus theta, right? Did you get which angle I am showing here? This angle, because this angle, this is total is 90 degree. This is theta. Obviously, this will be 90 minus theta. So, if you assume this is your triangle, if you assume this is 90, this is 90 minus theta, obviously this will be how much? This will be your theta. Did you get what I'm saying? क्या आपको समझ में आई? नहीं?
Yes, sir.
So this is theta and this is your D, right? This is your D. Now, if you assume this triangle, then what you can say? This will be your perpendicular. This will be your perpendicular, right? This will be a perpendicular. This will be your base, and this will be your hypotenuse. So you can find this path or this length. This length will be how much? Sin theta will be how much? Sin theta will be perpendicular. That will be this distance divided by hypotenuse. Hypotenuse is how much? D, right? So it means this distance will be how much? This distance will be sin theta into D. So this distance actually D is sin theta. And this is actually path difference between S1Q and S2Q. So you got that path difference between S1Q and S2Q, that is how much? D sin theta. Is there any doubt how I have came to conclusion that path difference between S1Q and S2Q, that is D sin theta? Do you have any doubt here? If you have doubt, please tell me. I can repeat.
No doubt. No, sir.
Sir, please repeat, sir.
Oh, okay, okay. So you see, I have made a perpendicular, right? I have drawn a perpendicular here. So perpendicular means this angle will be how much? This will be 90 degree, right? This is your ray. This is your ray. You have drawn a perpendicular. So obviously, the perpendicular means angle between ray and that line will be how much? 90 degree. Now see, this is your 90 degree you got, and this thing you have assumed that is theta. So this angle will be how much? This angle, this will be 90 minus theta, because this and these are perpendicular, right? So this angle will be how much? This angle will be 90 minus theta. So if you assume this is your triangle, this is your triangle, if you assume this is 90 degree, this is 90 minus theta. So obviously this angle will be how much? Theta. So that it will be 180. So you got this is your theta. Now if you assume this triangle if you assume, so this is your theta, this is perpendicular, and this is hypotenuse, this is base. So I have to calculate this perpendicular. This is actually the part difference between S1Q and S2Q. So sine theta, how will write sine theta? Sine theta is nothing but perpendicular divided by hypotenuse. So perpendicular will be how much? Hypotenuse into sine theta. Hypotenuse is how much here? D. So D into sine theta, that is your perpendicular, and that is actually part difference between these two rays, S1Q and S2Q. So you got this part difference, that is d sine theta. Now is it clear? Is it clear, or shall I have to repeat again? If you tell me, I can repeat also. Is it clear?
Yes, sir.
Okay. So you got
Yes, sir.
you got this part difference, right? D sine theta. Now, just a few minutes back, I told you for constructive interference, suppose this point is making constructive interference, or you are getting here a bright spot. It means the part difference किसका order में होना चाहिए आपका? किसका order में होना चाहिए?
N lambda.
It should be n lambda, right? And you know what is it? N should be either 0, 1, 2, and so on, right? It means you can say that sine theta, आपको आप लोगों को दिख रहा है इधर? कोई problem नहीं, right?
Yes.
हाँ, it means sine theta will be how much? N lambda by d, where n will be 0, 1, 2, and so on. Okay, now you see, lambda is basically of the order of Armstrong. Lambda is basically of the order of Armstrong. Lambda is what here? Lambda is wavelength of light that you are using. And D is the separation between slits, and that is basically in the unit of millimeter. ठीक है, तो ये जो आपका यूनिट है ये आपका एमस्ट्रॉम में है. एमस्ट्रॉम मतलब 10 की पावर माइनस 10 है, और डी आपका क्या है? बेसिकली मिलीमीटर ऑर्डर में 10 की पावर माइनस 3 है. तो देखो, अगर ये वैल्यू कैलकुलेट करोगे साइन थीटा, तो यू विल गेट ऑफ द ऑर्डर ऑफ 10 की पावर माइनस 7, 10 की पावर माइनस 10, और नीचे आपका क्या है? 10 की पावर माइनस 3 है. So we'll get basically sin theta value of the order of 10 to the power minus 7, and 10 to the power minus 7 is very small. So when sin theta is very small, what you can say? For very small value of sin theta will be equals to
Theta.
Exactly. So what I can say here, since this ratio is so small, I can write theta equals sin theta equals to theta, and that should be equals to L lambda by d. And when theta is small, again I can write in place of theta, what I can write? I can write tan theta, right? है ना? अच्छा, ये sin theta कब small होता है? Sin theta का वैल्यू कब small होता है? जब theta small होता है.
Yes, sir.
When theta is small, then sin theta will be small. And when theta will be small, you can write sin theta equals to theta. Again, when theta is small, you can write tan theta equals to theta. When theta is small, you can write tan theta equals to theta. So in place of theta, you can substitute tan theta.
Yes, sir.
Okay. So tan theta equals to how much? N lambda by d. Okay. Now what I am doing tan theta, because now I can calculate that tan theta in terms of known parameter. Because tan theta, if you assume this is your triangle, if you assume. Now for tan theta will be how much? This will be your perpendicular, and this will be your base, and base you know that is capital T, right? So what I can say, in place of tan theta, I can write, if you take this is your triangle, if you take, tan theta will be how much? This perpendicular, that will be yn divided by base is how much? That is capital. And that should be equals to how much? N lambda by small d. Okay. Did you get what I'm saying? Is it clear?
tan theta concept.
tan theta का कॉन्सेप्ट आपको समझ में नहीं आया? अच्छा अच्छा, देखो कंडीशन ऐसा होता है when theta is small, then you will get sin theta, you will get the value of sin theta, that will be very small. जब थीटा का वैल्यू बहुत छोटे होते हैं, if that theta is very small, sin theta क्या होता है? sin theta is very small, है ना? तो sin theta का वैल्यू आपको 10 की पावर -7 क्यों मिला था आपको? क्योंकि थीटा काफी स्मॉल है. Why you got that 10 to the power -7 sin theta equals to? Because theta is small. And when theta is small, you can write sin theta equals to theta. Also, you can write tan theta equals to theta. ठीक है? तो मैंने पहले sin theta से theta लिखा हूं, फिर theta से tan theta लिखा हूं.
Okay, sir.
Okay?
सर थीटा डिग्री में मेजर कर रहे हो आप?
Yes, theta degree. Theta should be in degree.
सर फिर n lambda by d की
No. नहीं, here यहाँ पे मैंने एक्चुअली क्या किया? थीटा को मैंने जस्ट आपको यहाँ से ये आपका डिग्री में रेडियन में है, इसको कन्वर्ट करने के लिए आपको 2 पाई बाय इसमें मल्टीप्लाई करना है, 2 पाई से इसमें 80 पाई बाय 80 से मल्टीप्लाई करना पड़ेगा.
yes sir.
Okay. Now you observe, what you have observed, the position of nth bright fringe, that will be how much? Yn equals to n d lambda by d, है ना? Yn क्या रिप्रेजेंट कर रहे हैं यहाँ पे?
and we constructive things.
Yn आपका रिप्रेजेंट कर रहा है पोजीशन ऑफ nth ब्राइट फ्रिंज, ठीक है ना? और n का वैल्यू क्या हो सकता है? n का वैल्यू हो सकता है 0, 1, 2, 3 सो ऑन, राइट? जब आप n का वैल्यू 0 रखोगे तो क्या रिप्रेजेंट करेगा? पोजीशन ऑफ सेंट्रल ब्राइट. So basically when you will substitute n equals to 0, you will get position of central bright. 0 means central bright, and it will be where? It will be at 0. 0 means here. ठीक है? ठीक है? Similarly, position of first bright will be where? Just you have to substitute how much? N equals to 1. So position of first bright will be at d lambda by small d. When n equals to 1. Similarly, you can calculate position of second bright. That will be how much? 2d lambda by d. Here, what I have substituted in place of small n, I have substituted n equals to 2. Right? Is it clear?
Yes sir.
Yes sir.
Okay. Now, what is fringe width? Fringe width, it is basically denoted by beta. Beta fringe width is nothing but separation between two consecutive bright or two consecutive dark. So what you can say, that separation between two consecutive bright, like y2b minus y1b, or in place of, you can simply write separation between two consecutive bright means what you can write, yn plus 1 beta minus yn, not beta, this will be capital B, sorry, yn. ठीक है ना? तो yn plus 1 b कितना हो जाएगा आप लोग बताओ जरा. Just I'll write like this, on n plus 1 d lambda by d, and yn b will be how much? N d lambda by small d. So it will be basically capital D lambda by small d. So this will be your fringe width. So fringe width is defined as separation between two consecutive bright fringes or two consecutive dark fringes, right? So here I have calculated by taking only consecutive bright fringes. Okay. Did you get everything here? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now I'll calculate the position of nth dark fringe. So again, I'll use that part difference. Part difference was how much? That was d sine theta, right? D sine theta. And for dark fringe, that condition was what? That was 2n minus 1 lambda by 2. So point Q that we have denoted, that will be dark when the part difference between two rays, that is S1Q and S2Q, that will be d sine theta. When d sine theta will be 2n minus 1 lambda by 2, then that point will be dark, right? Or you can say minimum intensity. Again, I will use same concept. So in place of, you know that lambda is very small, of the order of angstrom, d is of the order of millimeter. So in place of sine theta, directly I will use tan theta. So tan theta will be how much? That will be 2n minus 1 lambda by 2d, right? And tan theta will be how much? Again, same thing, yn by capital D. That should be equals to 2n minus 1 lambda by 2. It means position of nth dark fringe will be how much? 2n minus 1 कैपिटल डी लैम्डा बाय ट्वाइस। n का वैल्यू क्या क्या है यहाँ पे बताओ आप लोग, क्या क्या है n का वैल्यू यहाँ पे? So it is like if you remember, it is like 1 2 3 and so on, right? It is like 1 2 3 and so on. Is it clear? ठीक है ना? Is it clear to all?
सेंट्रल फ्रिंज हमेशा ब्राइट ही होगा।
हाँ, सेंट्रल फ्रिंज हमेशा ब्राइट होगा यहाँ पे, बट आप कोई अगर कोई मीडियम इंट्रोड्यूस करोगे, दैट इज योर नेक्स्ट पार्ट। अगर कोई मीडियम इंट्रोड्यूस करोगे फिर आपका शिफ्ट हो जाएगा, और इट विल नॉट ऑलवेज बी ब्राइट इफ यू इंट्रोड्यूस सम अदर मटेरियल लाइक ग्लास or other mica in place of in front of and slit. That will do in the next part, and that is your actually important for JAM exam. Okay, but here you will always get central bright. Okay, so position of first dark will be where? Y on D. It means Y on D means what? Position of first dark. So in place of n, how much I'll substitute? I'll substitute n equals to 1, right? So if you substitute n equals to 1, you will get capital D lambda by twice D. So this is the position of first dark. Position of second dark, it will be how much? It will be 3D lambda by twice D. When n equals to 2. Position of third dark. Okay, this will be 5D lambda by twice D. When n equals to 3. Okay, so if you calculate again the fringe width how much you will get? So if you take the formula for dark fringe to calculate the fringe width, again if you use same concept like y n plus 1 d minus y n d, again you will get capital D lambda by small d. So fringe width actually defined as separation between two consecutive bright fringes or dark fringes. So it is basically capital D lambda by small d. Capital D क्या है आपका? Separation between source or slit and screen. Small d means separation between two slits, and lambda that wavelength that you are using. Okay, and this is basically simple part. Now I'll ask an important question here. So suppose you you perform this young double slit experiment in air, and you observe the fringe width that is beta. Okay, please listen to me carefully. This is important part. Suppose you have performed this experiment in air and you got that fringe width that is beta. Now you shifted this whole experiment to some medium, to some oil Okay, and oil is having refractive index small n. Oil is having refractive index small n. Okay, now how much will be the fringe width when you are performing this experiment in oil having refractive index small n? So when you have performed this experiment in air, you are getting beta. So will it be same or different? Will it be same or different?
Different.
Yes,
सर
different.
वो सिर्फ वेवलेंथ पे डिपेंड करता है.
Exactly, वेवलेंथ के ऊपर डिपेंड करता है, बट आपको वेवलेंथ की जरूरत नहीं है.
Different.
Of course, it will be different, but how much it will be different? Anyone? So you have used this light having wavelength lambda in air. Okay, so lambda will be how much? The speed of light in air divided by क्या होता है बताओ? लैम्डा इक्वल्स टू क्या होता है बताओ आप लोग?
C on nu.
सी अपॉन ई इक्वल्स टू क्या होता है बताओ? एच सी बाय लैम्डा होता है ना. तो हाँ, यहाँ से आप लिख सकते हो. देखो लैम्डा, पहले आप ये कैलकुलेट करो, फ्रीक्वेंसी कैलकुलेट करो. जो लाइट आप यूज कर रहे हो, सपोज मान लो एयर में उसका वेवलेंथ लैम्डा है, तो उस लाइट का फ्रीक्वेंसी कितना हो जाएगा जब एयर में ट्रेवल कर रहा है और यू आर परफॉर्मिंग दिस एक्सपेरिमेंट इन एयर? द फ्रीक्वेंसी ऑफ दिस लाइट विल बी हाउ मच? द स्पीड ऑफ लाइट डिवाइड बाय wavelength, right? When you are performing this experiment in air. Now you are performing this experiment in oil having refractive index n. ठीक है ना? तो इसमें आपका जब लाइट जब एक मीडियम से दूसरे मीडियम में ट्रेवल करते हैं, कौन सा चीज आपका फिक्स रहता है? सो फर्स्ट यू हैव परफॉर्म दिस एक्सपेरिमेंट इन एयर, राइट? सो एयर में जो आपका फ्रीक्वेंसी होगा, लाइट जो सोर्स यूज किए हो उसका फ्रीक्वेंसी कितना है? न्यू कितना होगा? सी बाई लैम्डा. लैम्डा क्या है? उसका वेवलेंथ है. अब जब लाइट का कौन सा प्रॉपर्टी हमेशा अनचेंज रहता है मीडियम के साथ? वो है फ्रीक्वेंसी. चाहे आपका एयर में ट्रेवल करे, चाहे ऑयल में, चाहे वाटर में, उसका फ्रीक्वेंसी कभी चेंज नहीं होता है. तो जो फ्रीक्वेंसी उसका एयर में था वही ऑयल में भी रहेगा. वो कितना होगा आपका? न्यू क्या होता है? सी बाई लैम्डा. बट यहाँ पे सी नहीं रहेगा. जब मीडियम आपका चेंज ऑयल हो गया, वहां पे क्या लिखना पड़ेगा आपको?
C dash.
ही बाई, और सी डैश भी लिख सकते हो, बाई लैम्डा. ऑयल में कर रहे हो, सपोज मान लो लैम्डा वो लीजिए. ठीक है ना? अब यहाँ पे क्या करना पड़ेगा? भी को, भी इज नथिंग बट सी बाई एन लैम्डा जीरो. लैम्डा जीरो नहीं है यहाँ पे, एक्चुअली क्या है? लैम्डा ओ. लैम्डा ओ मतलब वेवलेंथ ऑफ लाइट इन ऑयल. ठीक है, यही न्यू इसके बराबर है, तो इसको आप बराबर कर सकते हो, लाइक सी बाई लैम्डा. सी कैंसिल हो जाएगा आपका, नहीं? तो देखो वेवलेंथ जो हो जाएगा आपका, जब वो ये लाइट आपका ऑयल में ट्रैवल कर रहा है, तो इसका वेवलेंथ कितना हो जाएगा अब? लैम्डा ओ, दैट विल बी हाउ मच? लैम्डा डिवाइड बाय एन. ठीक है ना? तो लैम्डा क्या रिप्रेजेंट कर रहे हैं? वेवलेंथ ऑफ लाइट इन फ्री स्पेस और एयर. वेवलेंथ ऑफ लाइट इन एयर. एन क्या है यहाँ पे? रिफ्रैक्टिव इंडेक्स ऑफ ऑयल. तो देखो जब आपका मीडियम चेंज हो गया आपका, तो लाइट का क्या है? वेवलेंथ बेसिकली चेंज हो गया. किसके ऊपर डिपेंड करेगा? ये रिफ्रैक्टिव इंडेक्स के ऊपर डिपेंड करेगा. तो इफ यू रिमेंबर दैट एक्सप्रेशन फॉर फ्रिंज विड्थ कितना था आपका? डी लैम्डा बाय स्मॉल डी, राइट? ठीक है ना? अब जब आप ऑयल में परफॉर्म कर रहे हो, तो बीटा डैश क्या हो जाएगा? डी तो एज इट इज रहेगा. लैम्डा के जगह पे क्या लिखोगे? लैम्डा वेवलेंथ ऑफ लाइट इन ऑयल डिवाइड बाय स्मॉल डी. ठीक है ना? अब लैम्डा वो कितना है आपका? लैम्डा एन बाय लैम्डा बाय एन. सो इफ यू सब्स्टिट्यूट इट, यू विल बेसिकली गेट डी लैम्डा बाय डी इनटू एन. सो यू विल बेसिकली गेट बीटा बाय एन. तो फ्रिंज विड्थ आपका छोटा हो जाएगा. क्या ये पार्ट क्लियर है? इज इट क्लियर टू ऑल?
सर जब मीडियम चेंज हो गया तब फ्रीक्वेंसी कभी चेंज नहीं होगा?
नहीं, वो कभी चेंज नहीं होता, प्रॉपर्टी होता है इलेक्ट्रोमैग्नेटिक वेव का.
ओके सर.
Wavelength will be changed, okay, but frequency will never be changed. So lambda यहाँ पे 0 नहीं है, आपका क्या है, lambda O है. O means क्या है, wavelength of light in oil. Okay, so that you can calculate in terms of wavelength of light in air divided by refractive index of, किसका refractive index है ये, किसका है ये,
मध्यम
oil का, right?
ऑयल का.
हाँ, तो ऑयल के लिए आप जो फ्रिंज विड्थ हम मैंने क्या जम किया, बीटा डैश, दैट विल बी डी बाई स्मॉल टी. लैम्डा के जगह पे क्या यूज करूंगा मैं, लैम्डा ओ यूज करूंगा, क्योंकि ये चेंज हो जाएगा. अब लैम्डा ओ को आप कैलकुलेट कर सकते हो इन टर्म्स ऑफ लैम्डा बाय यूजिंग रिफ्रैक्टिव इंडेक्स. So now fringe width will be beta dash will be beta by n. So this kind of question in JAM they may ask for on mark question. Okay, is it clear?
यस सर.
yes sir
Okay. Now another part of this young double slit experiment. Suppose you are calculating that resultant intensity at point Q. Suppose you are calculating resultant amplitude or intensity at point Q. So how will calculate? So again, I am drawing that same kind of picture or diagram. So this is your slit on, slit 2, separation is D, and this distance is capital D. Okay, and central point is denoted by P. Now I am looking that point Q. Okay, the intensity or amplitude at point Q. So like ray is coming, this angle I have denoted, that is theta, right? And okay, this was your diagram, right? So part difference between these two ray was how much? That was your d sine theta, right? This was your d sine theta. So again, I am looking that intensity at point Q in terms of amplitude. So let us assume that ray, that is the light that is passing through S1 slit on, the amplitude of this light is, let us assume this is A1. The light passing through S1 having amplitude A1. Light passing through S2 having amplitude, let us assume this is A2. And path difference between these two rays is how much? This is, I have assumed how much? D sine theta. Did you get what I'm saying? So there are rays passing through S1 and S2. Their amplitude is A1 and A2. The path difference between these two rays, S1Q and S2Q, that is how much? D sine theta. तो इनके बीच में phase difference कितना हो जाएगा? Let us assume phase difference is delta. Phase difference is nothing but 2 pi by lambda into path difference, d sine theta. So this will be your phase difference. Now the resultant amplitude at Q will be how much? Any1. So like amplitude is coming, A1 is coming at Q, A2 is coming at Q with some phase difference delta. So resultant amplitude at point Q will be how much? Let us denote this resultant amplitude, that is E of Q. कितना हो जाएगा? एक एम्पलीट्यूड आपका S1 से आ रहा है, जो लाइट पास हो रहा है S1 से, उसका एम्पलीट्यूड मैंने कितना एज्यूम किया? A1. S2 से जो पास हो रहा है उसका एम्पलीट्यूड मैंने कितना एज्यूम किया? A2. ठीक है, तो यहाँ पे रिजल्टेंट एम्पलीट्यूड कितना हो जाएगा? It will be A1 plus A2 exponential I delta, where delta is the phase difference between two rays. Now you can see, if phase difference between these two rays is 180, then resultant amplitude कितना हो जाएगा? अगर ये यहाँ पे 180 रखो, पाई रखोगे, कितना हो जाएगा आपका? A1 minus A2 हो जाएगा. Again I am repeating, amplitude A1 is coming from S1, A2 is coming from S2. Their path difference is how much? Path difference between these two rays is d sin theta. Phase difference will be how much? 2 pi by lambda. Phase difference is here. What here? Delta. That is 2 pi by lambda d sin theta. If the delta is phase difference, that resultant amplitude at q will be how much? That will be a1 plus a2 exponential I delta. So delta will be defined whether it will be constructive or destructive. अगर डेल्टा आपका 0, 2 पाई 4 पाई 6 पाई अगर हो तो फिर क्या मिलेगा आपका a1 प्लस a2 मिलेगा. तो ये आपका क्या है? कॉन्स्ट्रक्टिव इंटरफेरेंस है. अगर डेल्टा आपका पाई 3 पाई 5 पाई इस ऑर्डर में मिलेगा तो फिर रिजल्टेंट एम्पलीट्यूड क्या हो जाएगा? a1 minus a2. You know exponential I pi is how much? -1. So for destructive, you will get resultant amplitude at q, that will be a1 minus a2. That is possible when delta will be 0. Sorry, delta will be pi, 3 pi, 5 pi, so on. Constructive के लिए delta जब आपका 0, 2 pi, 4 pi, so on, तब आपका constructive मिलेगा. So this is your general expression, and this is really important for your exam purpose. So this is the amplitude at q. So what will be the intensity at q? So how will calculate intensity? Intensity is nothing but amplitude square, right? Or you can say E star E. So E star E, if you do, then how much you will get? Basically, you will get A1 plus A2 exponential minus I delta into A1 plus A2 exponential I delta. ठीक है? Since स्टार मतलब क्या है? कॉम्प्लेक्स कंजुगेट. A1 A2 क्या है? आपका रियल पैरामीटर है. तो फिर ये A1 A2 का कोई स्टार नहीं लगेगा. जस्ट यहाँ पे आपका प्लस आई डेल्टा के जगह पे माइनस आई डेल्टा हो जाएगा जब ई स्टार लिखोगे आप. और ई एज इट इज ऐसे रहेगा. ठीक है ना? इज इट क्लियर? क्या ये क्लियर है? सो
सर
नाउ
हम कॉम्प्लेक्स कॉन्जुगेट क्यों ले रहे हैं?
ये आपका इंटेंसिटी का डेफिनेशन है. जैसे आप इंटेंसिटी क्या लिखते हो? एम्पलीट्यूड का स्क्वायर लिखते हो ना.
स्क्वायर.
एक्चुअली इंटेंसिटी, हाँ, एम्पलीट्यूड ऐसे लिखते हैं हम. इंटेंसिटी इज मॉड ए स्क्वायर लिखते हैं. मॉड ए स्क्वायर का मतलब क्या है? ए स्टार ए होता है. नहीं, मॉड्यूलस तो यही होता है ना. कॉम्प्लेक्स कॉन्जुगेट इनटू सिंपल प्रोडक्ट ए स्टार ए, राइट? डू यू गेट व्हाट आई एम सेइंग?
Yes, sir.
यस सर.
हाँ, ये आपका इसका डेफिनेशन है. अब बताओ ये कितना हो जाएगा इंटेंसिटी? तो बेसिकली मैं क्या कैलकुलेट कर रहा हूँ, आप लोग बताओ जरा. मैं कैलकुलेट कर रहा हूँ कि एट पर्टिकुलर पॉइंट Q, so if two rays are coming and they have phase difference delta, general phase difference if they give you, then you can calculate that intensity at point Q if you know that phase difference. So for any arbitrary phase difference, you can easily calculate the intensity pattern. Okay, so I will be basically A1 plus A2. Resultant amplitude E will be basically A1 plus A2 exponential I delta. So if you know amplitude, you can calculate intensity just by using formula E star E. Okay, so how much it will be basically? कितना हो जाएगा? So basically it will be A1 square plus A2 square plus how much? So A1 square plus A2 square, right? And you will get two more term. If you combine them, you will basically get 2A1 A2 cos A1 A2. A1 A2 cosine of delta. ठीक है? A1 square plus A2 square. Now A1 A2 exponential I delta. From this term you will get A1 A2 exponential minus I delta. So if you combine last two term, you will get basically 2A1 A2 cosine delta. A1 square के जगह पे हम क्या लिख सकते हैं बताओ? Ion लिख सकते हैं. The intensity coming from slit on, that will be ion, because you know that in amplitude square is nothing but intensity. So ion plus A2 के जगह पे क्या लिख सकते हैं? A2 स्क्वायर के जगह पे I2 लिख सकते हैं. एंड रूट ओवर A1 A2 के जगह पे हम लिख सकते हैं रूट ओवर ion I2 cosine of delta. Ion is intensity coming from slit on, I2 is intensity coming from slit 2. And you know intensity is nothing but amplitude square. So A1 square is nothing but I1, A2 square is I2. And in place of A1, you can write root over I1, A2 root over I2. If you combine them, you will get root over I1 plus I2. Okay, is it clear?
Yes,
Yes,
sir.
sir.
Now, for constructive interference, for constructive interference क्या होगा आपका? डेल्टा किस ऑर्डर में होगा? 0 or 2 pi or 4 pi and so on, right? So at this case, you will get maximum intensity, and that will be how much? So cosine, this value will be how much? 1, right? So basically you will get I1 plus I2 plus 2 root over I1 I2. So you can write it like, you can write in this case, you can write like root over I1 square plus root over I2 square plus 2 root over I1 I2 जब आपका कंस्ट्रक्टिव इंटरफेरेंस होगा। तो देखो इसको आप क्या लिख सकते हो? इट विल बी बेसिकली give you maximum intensity, that will be root over I1 plus root over I2 का स्क्वायर, राइट? ठीक है ना? क्या मैं लिख सकता हूँ? नहीं?
Yes, sir.
So
Yes,
again,
sir.
you can write in terms of amplitude also. So in place of root over I1, you can write A1. In place of root over I2, you can write A2 square. ठीक है ना? क्या क्लियर है?
Yes, sir.
Second part, destructive interference. ठीक है? तो डिस्ट्रक्टिव इंटरफेरेंस के लिए आपका क्या है? डेल्टा किस ऑर्डर में होना चाहिए? आइदर पाई और 3 पाई और 5 पाई एंड सो ऑन, राइट? तो अब यहाँ पे अगर cos पाई रखोगे या 3 पाई रखोगे या 5 पाई रखोगे तो फिर क्या आ जाएगा आपका? माइनस होना जाएगा। तो in that scenario, what you will get basically? Here you will get basically minus, right? So you will basically get root over I1 square plus root over I2 square minus 2 root over I1 I2. So basically you will get minimum intensity, and that will be how much? Anyone? Root over I1 minus root over I2 square. So you can write in terms of amplitude like A1 minus A2 का square. क्या इतना क्लियर है?
Yes, sir.
आप लोगों को ब्रेक चाहिए या कंटिन्यू करें?
Continue, sir.
ओके, सब लोग एग्री?
Yes, sir.
Yes, sir.
I think
Yes, sir.
I think you people are enjoying class then. Okay, we can continue. क्या आप लोगों को समझ में आ रहा है?
Yes, sir.
Yes, sir. Yes, sir.
So what you learn if two rays are coming at any point on the screen, if you know the phase difference between two rays, then you can find that intensity at that point just by using formula A1 A2 exponential I delta. Okay, so for any delta you can calculate. Okay. Okay, now interesting question is that, so you have, if you remember, this is your problem actually. So you have, if you remember, you have two slits, right? S1 and S2. Okay. Now, what is given in that question? You have S1, S2, and you have screen. This is D. Okay. This is your screen. So what they are basically given, the width the width of slit on, that is 3 times the width of slit 2. Slit on का जो width है, that is 3 times the width of slit 2. You can take big and you can take this width is small. Okay, ठीक है, ये आपका given है. Also they told you the amplitude of ray coming through slit, the amplitude of ray coming through slit is proportional to slit width. So two things are given. One is width of slit on, that is thrice width of slit 2, and also they provided you, or they mentioned that the amplitude of ray coming through slit, that is proportional to slit width. Then what is the question? You have to calculate the ratio of maximum intensity to that of minimum intensity at the screen. You have to calculate the ratio of maximum intensity to that of minimum intensity at the screen. So two things are given: width of slit on thrice the width of slit 2, and amplitude of ray coming through slit is proportional to the slit width. Okay, how will calculate? So if you remember, just we have derived I max by I min. कितना था वो? I min. That is, if you remember, A1 plus A2 divided by A1 minus A2 का होल स्क्वायर, यही था ना? ठीक है ना?
Yes, sir.
हाँ, अब A1 क्या है? एम्पलीट्यूड ऑफ रे कमिंग थ्रू स्लिट ऑन. A2 क्या था? एम्पलीट्यूड ऑफ रे कमिंग थ्रू स्लिट 2. ठीक है ना? तो A1 के जगह पे आप क्या लिखोगे? जस्ट 3A2 लिख सकते हो आप? नहीं, क्योंकि, और इफ यू यही लिख सकते हो ना, क्योंकि इसका जो विड्थ है स्लिट 2 का, सॉरी स्लिट 1 का जो विड्थ है किसके बराबर है? दैट इज थ्राइस स्लिट विड्थ ऑफ S2, राइट? तो अगर A2 इसका एम्पलीट्यूड है, दैट इज पासिंग थ्रू स्लिट S2, so amplitude of ray that is passing through S1, that will be how much? That will be thrice of A2. According to that statement, that amplitude of ray passing through slit, that is proportional to slit width. तो अगर स्लिट विथ S1 का थ्राइस है तो एम्पलीट्यूड भी क्या हो जाएगा? A1 कितना होना चाहिए? थ्राइस A2 होना चाहिए, राइट? अगर S2 का एम्पलीट्यूड A2 है तो S1 का कितना होना चाहिए? थ्राइस A2 होना चाहिए, राइट?
ऐसे तो 4A2 हो जाएगा सर.
4A2 क्यों होगा?
1 इक्वल 3A2 हो जाएगा फिर तो सर. इससे जैसे S1 इक्वल 3S2 हो रहा है.
हाँ, S1 इक्वल टू 3
और A1 फिर जैसे A1 इक्वल 3A2 हो सकता है सर. सर एम्पलीट्यूड विड्थ पे डिपेंड रहता है.
हाँ, नहीं, यस, एम्पलीट्यूड विड्थ के ऊपर डिपेंड. दे हैव गिवन यू, they have provided you, they told you that amplitude of ray coming through slit, that is proportional to slit width. ठीक है, ये आपका गिवन है स्टेटमेंट. अब पूछा ये गया है मैक्सिमम इंटेंसिटी टू दैट ऑफ मिनिमम इंटेंसिटी एट द स्क्रीन. दे आस्क यू, now you know maximum intensity divided by minimum intensity, that is how much? A1 plus A2 divided by A1 minus A2. A1 क्या है? amplitude of ray coming through S1. ठीक है, A2 amplitude of ray coming through S2. अगर S1 का विथ S2 का तीन गुना ज्यादा है तो A1 कितना होना चाहिए? थ्राइस A2 होना चाहिए ना?
Yes, sir.
सपोज मान लो, अच्छा इसका मानो आप विथ, इसका मानो विथ डेल्टा, इसका विथ आप मानो S2 का विथ आप डेल्टा मानो, ठीक है? और इसका एम्पलीट्यूड आप मानो, जो रे पास हो रहा है इसका एम्पलीट्यूड मानो ये मानो, ठीक है? इसका एम्पलीट्यूड क्या, इसका विथ कितना हो जाएगा? बताओ, S1 का विथ कितना हो जाएगा?
3 into delta.
3 into डेल्टा हो जाएगा. एंड क्या बोला है कि अकॉर्डिंग टू द गिवन कंडीशन डेल्टा प्रोपोर्शनल टू व्हाट? A. तो 3 डेल्टा के जगह पे आप क्या लिखोगे, प्रोपोर्शनल टू 3a लिखोगे, ठीक है ना। तो एक्चुअली आपको a1 के जगह पे कितना लिखना पड़ेगा, 3a लिखना पड़ेगा, a2 के जगह पे क्या लिखना पड़ेगा, ये लिखना पड़ेगा, राइट।
Yes, sir.
हाँ, so we will basically get I max by I min. I max by I min, that will be how much? That will be 3a plus a divided by 3a minus a का whole square. So that will be how much basically? 4 by 2. So 4:1, right? 4:1, right? Or 4 by 1 you can say. You can say this is your 4. क्या ये क्लियर है आप लोगों को क्वेश्चन?
सर 4/2
Yes, sir.
होगा ना?
हाँ 4/2 मतलब 2 उसका स्क्वायर करोगे तो 4 ही मिलेगा ना आपको।
Got.
4/2 का स्क्वायर है तो 2 स्क्वायर मतलब 4 ही है ना। आप ये कहना चाह रहे हो ना कि 4/2
Yes sir, got it.
स्क्वायर, 2 का स्क्वायर दैट इज 4। ठीक है, इतना क्लियर है। आप लोग क्या सीखे हो बताओ यंग डबल स्लिट का। फर्स्ट ऑफ ऑल वेव नेचर है ना। दूसरा कॉन्सेप्ट ये है जो मिसकॉन्सेप्शन था आपका कि लाइट ऑलवेज फॉलो द स्ट्रेट लाइन पाथ, दैट इज ऑल्सो नॉट ट्रू। ठीक है, दो चीज। और दूसरा चीज जो आपका पैटर्न का जो आपका ये है इंटेंसिटी का जो ये पैटर्न है, दैट वी हैव लर्न, राइट। इज इट क्लियर टू ऑल? Okay, if it is clear, then we can go to complicated question. ये सबको क्लियर है ये वाला क्वेश्चन?
Yes, sir.
Yes sir.
ठीक है, सिका आपको क्लियर है?
Sir, clear.
Okay. Okay, then we are going to next problem, that is problem number 2. Okay, so suppose you have a, now you have a 3 slits actually, not 2 slits. Okay, and this is your S1 slit, this is your S2, this is your S3. Okay, this separation between S1 and S2, that is small d. Separation between S2 and S3, that is your twice d. And you have a screen. You have a screen at a d distance away, or you can say capital D distance away. Okay. And they have given you, this is your point P, and at point Q we have to calculate the intensity pattern. This angle they have provided. You can manage, you draw it properly. This point is Q here. This angle they have given, that is theta. Okay, and also they have given that delta equals to 2 pi by lambda d sine theta. So I am repeating this question, it is better to repeat. So you have 3 slits, S1, S2, S3. Separation between S1 and S2, that is small d. Separation between S2 and S3, that is twice d. Okay, and separation between slits and screen, that is capital D. And this is your some point P. At point Q you have to calculate that intensity pattern in terms of delta, and delta they have provided. Delta is how much? 2 pi by lambda d sine theta. Lambda is here that wavelength that you are using. Okay, so can you able to calculate intensity pattern at point Q in terms of delta? Anyone? Okay, so if they didn't give you any intensity amplitude, they didn't mention about that amplitude, so we have to take amplitude same. So amplitude of ray coming through S1, that is A. Amplitude of ray coming through S2, that is A2. Okay, anyway, someone was asking that about how that amplitude is depends, right? Anyone was asking, right? I forgot to tell. Who was asking this question? Anyone? Please respond me. कोई आप लोग कोई पूछ रहे थे ना कि एम्पलीट्यूड किसके ऊपर डिपेंड करता है?
Yes, sir.
हाँ, who was asking?
Sir, amplitude width पर depend करता है.
हाँ, एम्पलीट्यूड विथ के ऊपर डिपेंड करता है. तो यहाँ पे क्या है, देखो आपका 3 स्लिट से है ना, तो यहाँ से S1 से जो रे पास हो रहा है उसका एम्पलीट्यूड यहाँ पे कुछ मेंशन नहीं किया कि एम्पलीट्यूड इसका विड्थ कितना है स्लिट का. तो आई हैव टेकन एम्पलीट्यूड सॉरी आइडेंटिकल विड्थ मैंने अज्यूम किया तीनों स्लिट्स का. तो तीनों का जो रे तीनों में जो रे पास होगा तीनों का एम्पलीट्यूड क्या होगा, बराबर होगा. इफ दे डिडंट मेंशन अबाउट दैट विड्थ, सो यू हैव टू टेक सेम width. So if the width is same, then the amplitude of ray that is passing through this slit that will be same. ठीक है. तो यहाँ से जो रे पास हो रहा है एम्पलीट्यूड ए है, यहाँ से जो पास हो रहा है इसका भी एम्पलीट्यूड ए है, S3 से जो पास हो रहा है इनका भी एम्पलीट्यूड ए है. ठीक है. अब बताओ S1 और S2 के बीच में जो रे है इनका फेज डिफरेंस कितना हो जाएगा? कितना हो जाएगा? ray is coming from S1 meeting here, ray is coming from S2 meeting here. So how much will be the phase difference between these two rays, S1Q and S2Q? That just we have calculated. How much it is? 2 pi by lambda d sin theta, right? भाई इनके बीच में पार्ट डिफरेंस कितना हो जाएगा? d sin theta हो जाएगा. S1 S2 के बीच में पार्ट डिफरेंस कितना हो जाएगा? d sin theta. If part difference is d sin theta, phase difference कितना हो जाएगा? 2 pi by lambda d sin theta, है ना? ठीक है. तो इनके बीच में मेरे को फेज डिफरेंस पता चल गया. दैट इज कितना है? डेल्टा है. ओके. पार्ट डिफरेंस S1 और S3 के बीच में कितना हो जाएगा? ये सेपरेशन कितना है? D प्लस 2D 3D. तो ये पार्ट डिफरेंस जो मिलेगा कितना मिलेगा? D के जगह पे कितना हो जाएगा? 3D हो जाएगा. तो पार्ट डिफरेंस बिटवीन S1 एंड S3 दैट विल बी हाउ मच? 3D sin theta. Because now hypotenuse will be how much? D plus 2D, that will be 3D. So if you say apply same rule, now your hypotenuse is how much? 3D. So obviously that part difference will be how much? Part difference between S1 and S3, that will be how much? That will be 3D sin theta. So if the part difference is 3D sin theta, obviously the phase difference will be how much? So if you substitute 3D here in place of D, if you substitute 3 here, 3D, phase difference कितना हो जाएगा? अगर इस फॉर्मूले से अगर 3 से मल्टीप्लाई करोगे तो फिर क्या मिलेगा आपको? 2 पाई बाई लैम्डा 3D sin थीटा. ठीक है. तो बेसिकली जो पार्ट डिफरेंस S1 और S3 के बीच में होगा कितना होगा? वो आपका 3 डेल्टा होगा. क्या क्लियर है ये बोला?
Yes, sir. Yes.
Yes, sir.
अगर यहाँ से सेम थिंग अगर यहाँ पे आप परपेंडिकुलर ड्रॉ करोगे, ठीक है ना, तो ये आपका ये थीटा हो जाएगा, ये आपका हाइपोटेनस हो जाएगा. हाइपोटेनस कितना है? D प्लस D सॉरी 2D प्लस D, दैट इज 3D. This is your perpendicular. So this perpendicular will be how much? 3D sin theta. Okay, and they have given you delta, that is 2 pi by lambda d sin theta. So if you multiply it by 3 delta will be 2 pi by lambda 3D sin theta. So it means the part difference between S1 and S3 that will be 3 delta. Now you can calculate that amplitude at point Q. That will be how much? Anyone? Amplitude at point Q will be how much? S1 से जो होगा आपका A ही रहेगा. S2 से क्या करना पड़ेगा आपको? A एक्सपोनेंशियल I डेल्टा करना पड़ेगा. एंड S3 से जो पास होगा कितना करना पड़ेगा? A एक्सपोनेंशियल 3I डेल्टा. क्या ये क्लियर है आप लोग? अगर क्लियर नहीं है प्लीज टेल मी. इज इट क्लियर और नॉट?
Clear, sir.
ओके. सबको क्लियर है ये 3I डेल्टा क्यों हुआ बताओ?
3 से पास हो रहा है.
हाँ, क्योंकि वो फेज डिफरेंस S1 और S3 के बीच में कितना आया है? अब 3 डेल्टा आया, राइट? दैट्स व्हाई I have taken exponential 3I delta. ठीक है. So I have taken this as a reference and I have calculated the phase difference. So phase difference between S1 and S2, that is delta, then the phase difference between S1 and S3, that will be 3 delta. So if you have, if you know that amplitude, now you can clearly easily calculate that intensity. Intensity at point Q will be how much? That will be your E star at point Q into E at point Q. Okay. So if you substitute it, you will basically get. So now let us take amplitude A common. So if you take A common, it will be how much? On plus exponential minus I delta plus exponential minus 3I delta, right? That is from E star, right? And same thing from E, how much you will get? You will basically get capital A into on plus exponential I delta plus exponential 3I delta. Okay. So A into A, that will be your A square, right? Now you see on into on, that will be on. Exponential, if you multiply exponential minus I delta with exponential plus I delta, you will basically get 1. When you will multiply the exponential minus 3I delta with exponential plus 3I delta, you will again get plus 1. So you will basically get 3. कब 3 मिलेगा? जब on के साथ on multiply करोगे, एक on मिलेगा. जब exponential minus I delta के साथ exponential plus I delta का multiply करोगे, you will get 1. When you multiply exponential minus 3I delta with exponential plus 3I delta, you will again get plus 1. So you will get basically 3. अब देखो, एक टर्म यहाँ पे आएगा जब आपका ऑन के साथ एक्सपोनेंशियल आई डेल्टा का मल्टीप्लाई होगा. क्या मिलेगा आपको? एक्सपोनेंशियल आई डेल्टा मिलेगा. जब ये ऑन एक्सपोनेंशियल माइनस आई डेल्टा के साथ मल्टीप्लाई होगा, फिर क्या मिलेगा आपको? एक्सपोनेंशियल माइनस आई डेल्टा. So we'll basically get two term, that is exponential I delta plus exponential minus I delta. That will be how much? Twice cos delta. जब ये टर्म के साथ ये मल्टीप्लाई करोगे क्या मिलेगा? एक्सपोनेंशियल आई डेल्टा मिलेगा. जब इसके साथ इसका मल्टीप्लाई करोगे एक्सपोनेंशियल माइनस आई डेल्टा मिलेगा. अगर दोनों को कंबाइन करोगे क्या मिलेगा?
cos
Twice
delta.
cos delta. Twice cos delta मिलेगा, राइट? ओके. सिमिलरली जब इस टर्म के साथ इसका मल्टीप्लाई करोगे क्या मिलेगा आपको? एक्सपोनेंशियल माइनस 3i डेल्टा मिलेगा. जब इसके साथ इसका मल्टीप्लाई करोगे क्या मिलेगा आपको? एक्सपोनेंशियल प्लस 3i डेल्टा मिलेगा. अगर दोनों को कंबाइन करोगे फिर क्या मिलेगा आपको? ट्वाइस कॉस ऑफ 3 डेल्टा. ट्वाइस कॉस ऑफ 3 डेल्टा मिलेगा. ठीक है. अगेन जब आपका एक्सपोनेंशियल माइनस आई डेल्टा के साथ एक्सपोनेंशियल प्लस 3i डेल्टा का मल्टीप्लाई होगा फिर क्या मिलेगा आपको? इसके साथ अगर इसका मल्टीप्लाई करोगे आपको मिलेगा एक्सपोनेंशियल ट्वाइस आई डेल्टा. यू विल गेट एक्सपोनेंशियल ट्वाइस आई डेल्टा, राइट? व्हेन यू मल्टीप्लाई दिस टर्म विद दिस टर्म you will get exponential minus twice I delta. Now if you combine them, how much you will get? You will basically get twice exponential cos 2 delta. So these are the term you will get. क्या ये क्लियर है आप लोगों को? हाँ,
Sir, clear है.
सबको क्लियर है?
Yes, sir.
Yes, sir.
किशोर,
Yes, sir.
राम, कार्तिक, सब क्लियर है? अंजू, okay. So this will be the intensity pattern at point Q. So you can clearly notice from here that intensity is basically depends upon what? Phase factor, right? Phase difference, that is delta. Okay. So now you learn that intensity pattern due to 3 slits at any point if you know the phase difference. So for this type of question, what you have to do, you have to take one slit as a reference and then you have to calculate that phase difference with respect to S1. So phase difference between S1 and S2, phase difference between S1 and S3. Then you have to use that general formula, that is A plus A exponential I delta and so on. This is your amplitude formula. If you know amplitude formula, then you can easily calculate that intensity pattern just by making A star A or E star E, whatever it is. Okay. So 3 slits is really important, not only for your JAM, for any other exam like NET also. So this is actually question that I have given you from CSIR NET. Now next problem will be also more interesting, that is general problem. So if you understood this problem, next problem you please you people please respond. Okay, आप लोगों को सब क्लियर है ये क्वेश्चन?
Sir.
Yes, sir.
Yes, sir.
ठीक, आपको क्लियर है? आप लोगों का ओएब्स का अभी डाउट क्लास होंगे ना, एक टेस्ट हो गया आप लोगों का? Okay, now next problem, problem number 3. Again, you have 3 slits. Okay. Okay. A, B, C. 3 slits are there. S1, S2, S3. And separation between slit A and B, that is T. Separation between B and C, that is T. Okay. And you have a screen. Oh, sorry. You have a screen here. Okay. That separation between slits and screen that is given, that is capital D. And you are considering a point on the screen, that is P. You are considering a point on the screen, that is P, that is at same vertical line as slit C. So you are considering a point on the screen that is at same vertical line as slit C or S3 you can say. ठीक है? अब आपको given है that D given है, small d is given. Small d is how much? Twice d lambda by 3, that is given. ठीक है? आपको प्रूव क्या करनी है? प्रूव करना है the part difference between ray that is coming from. So what you have to calculate? You have to calculate the part difference that of ray between that is coming from slit B and C, that will be lambda by 3. Again I am repeating. So you have a 3 slit S1, S2 and S3 or A, B, C. Separation between 2 successive slits is small d. Separation between slits and screen, that is capital D. And you are considering a point P that is at same vertical line as slit S3. And small d is given, that is twice d lambda by 3, that is given. Now what you have to calculate? You have to calculate the part difference BP minus CP, that you have to calculate, sorry, CP that you have to calculate, that will be lambda by 3. You have to prove this. Okay, you have to prove this BP minus CP, that part difference will be lambda by 3. Okay, and also you have to calculate the intensity at point P. Intensity at point P will be 3a square. Okay, where a is the amplitude of ray coming from each slit. So सारे स्लिट से जो रे पास हो रहा है उसका एम्पलीट्यूड क्या है? ये है. So resultant intensity at point P will be how much? 3a square, that you have to prove. So 2 things you have to prove. One is part difference between BP and CP, that will be lambda by 3. Another thing, intensity at point P will be 3a square, where a is the amplitude of ray coming from each slit. मतलब S1 से जो लाइट पास हो रहा है उसका एम्पलीट्यूड a है, S2 से जो पास हो रहा है उसका भी एम्पलीट्यूड a है, S3 से जो पास हो रहा है उसका भी एम्पलीट्यूड a है. So resultant intensity at point P will be 3a square, that you have to prove. So 2 things you have to prove. And also they have given you this condition that lambda capital D is much greater than small d. Okay. So to do this, first let us calculate that BP. BP will be how much? So if you consider this this is as a right triangle, then how much you'll get? BP कितना आ जाएगा बताओ? BP will be how much? So this will be your hypotenuse, right? So BP will be basically, tell me how much it will be? Capital D square plus
Square
small d square,
minus
right?
small.
And CP will be how much? Just it will be capital D, right? CP कितना है? सेम वर्टिकल लाइन पे है, तो यही डिस्टेंस है ना? कितना है वो आपका? कैपिटल डी है, ठीक है ना? ठीक है. Now BP minus CP. BP minus CP, that I can write capital T square plus small d square minus d. Now I'll take d, capital D common. So what I can write from here? I can write 1 plus small d by capital D whole square minus 1. Okay. Now according to this condition, capital D much greater than small d, what I can write, that this factor will be smaller, much smaller than 1, right? जो आपका स्मॉल डी बाई कैपिटल डी का होल स्क्वायर, ये फैक्टर क्या हो जाएगा? ये एक से बहुत छोटा हो जाएगा. तो फिर अगर इसका बाइनोमियल एक्सपेंशन करोगे आप, तो फिर क्या मिलेगा आपको यहाँ से? कैपिटल डी इंटू 1 प्लस 1/2 डी स्क्वायर बाई capital D square, and you have minus 1, because you know 1 plus x की power n will be 1 plus nx. कब? जब x 1 से बहुत छोटा है ना? So I have done just like this, because n is how much here? N is nothing but 1/2, because this power is 1/2. Now 1 will be cancelled, and you will basically get BP minus CP कितना आ जाएगा बताओ? BP minus CP, that you will basically get small d square by twice d, ठीक है ना? एंड स्मॉल d कितना था आपका? गिवन था 2d lambda by 3, right? 2d by lambda by 3 square. If you remember, that was given, that was कितना था ये? 2d lambda by 3 था ना? तो अगर सब्स्टिट्यूट करोगे फिर क्या मिलेगा आपको? अगर d के जगह, स्मॉल d के जगह सब्स्टिट्यूट करोगे, आपको मिलेगा lambda by 3, ठीक है? तो पार्ट डिफरेंस बिटवीन ray coming from B and C slits, that will be how much? That will be lambda by 3. That we have proven. अब इंटेंसिटी के लिए क्या करना पड़ेगा? ठीक है. सो यहाँ से जो रे पास हो रहा है, सपोज मान लो ये है एम्पलीट्यूड, इससे भी S2 से जो पास हो रहा है, इसका भी एम्पलीट्यूड A मानो, S1 से इसका भी एम्पलीट्यूड A मानो. अब मैं C स्लिट्स को मैं रेफरेंस मान रहा हूँ, ठीक है? तो S3 और S2 के बीच में फेज डिफरेंस कितना आ जाएगा बताओ? डेल्टा कितना आ जाएगा? 2 पाई बाई लैम्डा इनटू पार्ट डिफरेंस. पार्ट डिफरेंस कितना है? लैम्डा बाई 3. ये कैंसिल हो जाएगा, तो 2 पाई बाई 3 आ गया. तो पार्ट डिफरेंस बिटवीन टू रेज coming from S3 and S2, that will be how much? 2 pi by 3. ठीक है. Okay. Now similar to this, can we calculate? So this is the phase difference, right? Phase difference between S3 and S2. अच्छा. BP minus CP is how much? Lambda by 3. Now can we calculate like AP minus CP कितना हो जाएगा बताओ? AP minus CP कितना हो जाएगा? So first of all आप बताओ AP कितना होगा? If you calculate AP. अच्छा, AP क्यों कैलकुलेट कर रहा हूं मैं? क्योंकि पार्ट डिफरेंस अगर मेरे को पता है, अगर AP और CP के बीच में पार्ट डिफरेंस, इफ आई एबल टू कैलकुलेट, then I can calculate phase difference between these two rays also. So we already have calculated that phase difference between two rays coming from C and B slits. That phase difference is how much? 2 pi by 3. So I can write that amplitude formula for C and B slit, but I cannot calculate or write the phase difference, amplitude formula for slit number A. So for that I need to calculate that phase difference. So for phase difference calculation, I have to calculate the part difference. So part difference, how I will calculate? AP कितना हो जाएगा जरा बताओ? तो ये लेंथ कितना हो
Root
जाएगा?
of
हाँ, so
d square plus 4d square.
हाँ, d square plus twice d square or 4d square you can say. Now AP minus CP कितना हो जाएगा बताओ? AP minus CP कितना हो जाएगा? If you calculate like by using same approximation like this. So I am leaving this, you will basically get 2 small d square by capital D. You do at home, okay? If you calculate this by using that previous concept, so you will basically get 2d square by small d, sorry capital D. और इसका वैल्यू सब्स्टिट्यूट करोगे फिर कितना मिलेगा आपको बताओ?
4 lambda by 3.
4 lambda by 3. So now you have calculated the phase difference between these two rays, CP and AP. So how much will be the part difference? Part difference you have calculated between two rays coming from slit C and slit A. That is 4 lambda by 3. Now how much will be the phase difference? Phase difference कितना हो जाएगा?
8 pi by 3.
So let us take that is delta prime, that will be 2 pi by lambda into 4 lambda by 3. So it will be basically 8 pi by 3. Okay. Now I can write that amplitude formula for point P. That will be how much? So E will be at point P. That will be how much? So I can write like A plus A exponential I 2 pi by 3 plus last term will be A exponential 8 pi I by 3. ठीक है? Is it clear? अच्छा, एक्सपोनेंशियल 8 पाई आई पाई बाई 3 को क्या लिख सकते हैं हम? अच्छा, इतना सबको क्लियर है आप लोगों को? इतना आप लोगों को क्लियर है
Yes, sir.
सबको?
Yes, sir.
ओके, जरा इसको बताओ, क्या मैं जो लास्ट टर्म है इसको मैं इस तरह से लिख सकता हूँ? जो आपका एक्सपोनेंशियल 8 पाई आई बाई 3 है, इसको मैं इस तरह से लिख सकता हूँ, एक्सपोनेंशियल 2 पाई प्लस 2 पाई बाई 3 इंटू आई लिख सकता हूँ?
Yes, sir.
हाँ, तो इसका दो पार्ट आ जाएगा, एक क्या आ जाएगा, एक्सपोनेंशियल 2 पाई आई इंटू एक्सपोनेंशियल 2 पाई आई बाई 3 आ जाएगा, दो पार्ट आ जाएगा ना। इसको अगर फर्दर लिखोगे किस तरह से लिख सकते हो आप? एक्सपोनेंशियल 2 पाई आई इंटू एक्सपोनेंशियल 2 पाई आई बाई 3 लिख सकते हो, नहीं लिख सकते हैं ना भाई? एक्सपोनेंशियल,
Yes, sir.
हाँ, अब ये वाला फैक्टर कितना है?
1.
1 है, तो व्हाट आई कैन राइट इन प्लेस ऑफ एक्सपोनेंशियल 8 पाई आई बाई 3 के जगह पे हम क्या लिख सकते हैं? एक्सपोनेंशियल 2 पाई आई बाई 3 लिख सकते हैं, नहीं? एंड दैट विल बी सेम एज सेकंड टर्म. So what I can write? I can just like write a plus 2a exponential 2 pi I by 3. ठीक है ना?
Yes, sir.
Okay. Now intensity at point P will be how much? That will be your E star at point P into E at point P. So if you substitute it, you have a plus 2a exponential minus 2 pi I by 3. Okay. And you have second term a plus 2a exponential 2 pi I by 3. Okay. Okay. So when you will multiply a with a, you will get a square. When you will multiply this term with this term, how much you will get? When you will multiply this term with this term, so exponential part will be cancelled. You will basically get 4a square. Okay. Now, when you will multiply this term with this term, how much you will get? 2a square exponential 2 pi I by 3, right? When you will multiply this term with this term, you'll get 2a square exponential 2 pi I by 3. When you multiply this term with this term, you will get 2a square exponential minus 2 pi I by 3. Now, from last two term, you will get 2a square common, and you will have exponential 2 pi I by 3 minus plus exponential minus 2 pi I by 3. अगर दोनों को combine करोगे आपको क्या मिलेगा basically? You'll get
cos.
for a square cos of 2 pi by 3. ठीक है, जस्ट कैलकुलेट करना आप लोग, इनके साथ इनका मल्टीप्लीकेशन, इनके साथ इनका मल्टीप्लीकेशन, और दोनों को फिर कंबाइन करके आपको 2a स्क्वायर कॉमन मिलेगा, एंड यू विल गेट 2 cos 2 pi by 3 factor. So if you combine, you will get 4a square cos 2 pi by 3. cos 2 pi by 3 का वैल्यू कितना होता है? हाँ भाई, कितना होता है cos 2 pi by 3 का वैल्यू? माइनस हाफ, राइट? cos 2 pi by 3 बेसिकली कितना है? माइनस हाफ, राइट? So you'll basically get 4a square by 2. So it means you'll get 3a square. Is it clear what I'm saying? Is it clear to all? कोई डाउट है इनमें? किसी का कोई डाउट है इसमें?
No, sir.
Okay. So what you have learned today? Is it clear? You learned about 3 slits, right? How to calculate it, that intensity pattern if they provide you 3 slits. Okay, even if they provide you more than 3 slits, then also you can calculate just by using same concept. Just you have to take one slit as a reference, and you have to calculate that phase difference for other slit. Okay, and you have to take this phase phase factor. Okay, now if you are able to calculate, if you are able to write that amplitude form, then you can easily calculate that intensity pattern. So I think this thing is new for all, and I think you will enjoy this part, right? So if you are able to calculate that amplitude pattern by using that concept of phase, then you can easily calculate that intensity pattern at any point. And this thing is really interesting when you are using multiple slits, not only limited to 2 slits, when you are using 3 slits, 4 slits, and this is important for your exam also. Not only limited to JAM, for other exam also this is important. So if you understood this part, then we'll proceed next part tomorrow. Is it clear to all?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, then we should stop here. Okay, tomorrow we'll discuss next part. Okay.
Okay, sir.
Yes, sir. Good night, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Good night, sir.